right, so back to the first part of the thermodynamics information. I think we covered this already. Thermodynamics is a study of energy changes. Energy is the ability to do work or produce heat. Work is a force acting over a distance. The first law of thermodynamics: during an interaction between a system and its surroundings, the amount of energy gained by the system is equal to the amount of energy lost by the surroundings. So in other words, our energy conservation. Energy can neither be created nor destroyed. It has to go somewhere. So the amount that you have before has to equal the amount that you have after. It's just a matter of whether it's part of the system or whether it's part of the surroundings, or vice versa. And then we've got the change in internal energy of a system is equal to the heat added to the system minus the work done by the system. And I don't know that we'll get into this a whole lot, but that's one way to look at it. The heat added minus the work done gives you your change. Okay, the second law of thermodynamics: in all energy exchanges, if no energy enters or leaves the system, the total energy of the state will always be less than that of the initial state. So this is where we can talk about kind of the loss of energy. So if we have our original temperature, our heat, as it's transferring, or as it's going to a different system, we will have some waste, is one way to put it. So here, if we have a hot reservoir, we have our heat energy. Some of it's going to be lost. The rest of it's going to be transferred to the cold. Extracting heat and using it all to do work would constitute a perfect heat engine forbidden by the second law. So we're going to have some work done, which is going to essentially leave the system. Work can go into the system. So all real refrigerators require work to get heat to flow from a cold area to a warmer area. And then here, spontaneous flow of heat from a cold area to a hot area would constitute a perfect refrigerator, which is forbidden by the second law. So this isn't going to happen. There's going to be some work either going into the system or that's going out of the system. So there's always going to be a change. There's always going to be some work, or we can consider it kind of a waste. The third law of thermodynamics: a perfect crystal at 0 Kelvin, which is absolute zero, has zero entropy. What is entropy? Entropy is the amount of disarray. So a crystalline structure, which would be what you would expect at 0 Kelvin, is not going to have any disarray. It's very organized. Polycrystalline has some disarray, and amorphous has even more disarray. So how organized is it? Is essentially one way to look at that. I don't expect you to memorize all of these. I want you to kind of have an idea of what they mean, but you don't have to memorize them.